and a lot of times I'll just call it a root. The number inside the radical, that is called the radicand. And you may or may not know this, but when there's actually a number written right here, sort of at the peak of the radical or the check mark of the radical. And if there's no number there, it's implied that it's a 2. And that number is called the index. And you're going to see, and we're going to do it in this chapter, that index is going to change. So sometimes if there's no index written, it's implied that it's an index of 2. Sometimes it's an index of 3. Sometimes there's an index of 4. There can be an index of 5. There could be an index of any number. And basically what that's asking you is what number times itself as many times as the index says gives you that radicand. So for example, if I have the index of 3, this is called the cubed root of 8. It's saying what number times itself 3 times gives me 8? 2, right? So that number, that index changes how we approach the problem. For the purpose of today, all our indexes will be 2, so we don't need to worry about it. All right, so our first thing we're going to go over is how to simplify a radical. Eventually, I would love for you to just be able to simplify in your head to make it quicker. But what's happening is we look at the index. There's no index written. What does that mean? The index is 2. What does that 3 in front mean? Yeah, this is saying 3 times the square root of 72. It's almost like a coefficient. You know how we have 3x, 3 is the coefficient. So it's saying 3 times the square root of 72. When we come to simplify this, what we're doing is we're looking at whatever that index is. There's no index written, so it's implied that it's a 2. And that's saying I need pairs. I want pairs to pull out. So I break this down into factors. And my point of factors is not to bring it down into primes, it's to get pairs out of it. So my best 2 factors to start off with are 36 and 2. Why do you think I started off with 36 and 2 and not 8 and 9?
Because 36 is a perfect square.
Yeah, because 36 is a perfect square, so it gives me a pair. 36 becomes 6 and 6. So remember, my goal is not to break down into primes. My goal is to get as many pairs as possible. So I have a pair of 6s, so I'm going to circle those. Whatever we circle comes on the outside 1 time. So I circled 1 pair of 6, so 1 6 is coming on the outside. And whatever's not crossed off and not circled goes back on the inside. So that 2 goes back on the inside. So now I have a 3 on the outside and I have a 6 on the outside. That's not 36. You're going to multiply those. 3 times 6 is 18. I don't need to see this work. I would really love for you to be able to simplify radicals in your head because that will save you time on the test. This is not like the point of this chapter. This is like the baby stuff. This is the baby stuff we're going to build off of. So the more you practice simplifying radicals, the better you're going to get at it. So let's try the other one. So you guys try this. 5 times the root of 24. So when we break this down, you can go 12 and 2, you can go 3 and 8. It's not wrong, but what's the best factors to start with? 6 and 4, because 4 is the biggest perfect square that goes into 24. But let's say you chose, I don't know, 2 and 12. Let's just pretend. So then what you're going to do is you're going to break that 12 down into 2 and 6. And then you can circle from different branches. So I'm going to circle the 2's there. Now, after I circle the 2's, I can still break down that 6 into 2 and 3, but why is there no point in breaking down that 6? Lucas? There's no other pairs. So now how many 2's are coming out? Just 1. So 5 times 2 is 10, and then you have the root 6. And you guys should have done this a lot in geometry when you guys were in your triangles unit, hopefully. Okay, now let's simplify variables. And we're going to say all variables are greater than or equal to 0. So meaning they're positive numbers. So we won't end up with a negative number in our radical. So it's the same idea. Let's say I have the square root of x to the 5th power. X to the 5th power is x times x times x times x times x, right? 5 x's multiplied together. And so if we're looking for pairs, here's a pair, here's another pair. So how many x's are getting brought outside? 2. So it's not 2x. What is it going to be? X squared, and there's 1x left over. So when we have the square root of x to the 5th power, we simplified that to x squared root x. Now there's a shortcut. Let me know if you think you know the shortcut. If I have the square root of x to the 8th power, can somebody tell me what's that going to be? Arav?
Yes.
Yeah, it's going to be x to the 4th. If you think you know this shortcut, can somebody tell me what would be the square root of x to the 11th power? Justin? X to the 5th root x. If you think you know the shortcut, what would be the square root of x to the 3rd power? Stephen? X root x. What is the shortcut? Rihan? Good. So you divide by 2, whatever that quotient is your exponent on the outside. Whatever the remainder is how the exponent on the inside. So for example, we had x to the 5th power. 5 divided 2 goes into 5 how many times? Twice. So we had x to the 2nd on the outside. And there was a remainder of 1. That means there's 1x left on the inside.
For all variables being above 0, is that just for the entire unit, so we'll never have to do it?
Yeah. Yes. Okay, let's keep going. Let's put now numbers and variables together. Let's say we have the square root of 24x to the 3rd. So if there's multiplication between the radicands, we can treat them separately. We could treat this like the square root of 24 times the square root of x to the 3rd. Do you think we can split it if there's a plus or minus sign? Never, ever, ever. So the square root of 24, I'd like to do this in our heads. Anybody able to do the square root of 24 in your head? Pranav? 2x root 6x? What? I'm confused. So I'm just saying 24. Just the square root of 24. What'd you get? 2 root 6. You got it. All right. Oh, I see what you did. Okay. Then the square root of x to the 3rd. 2 goes into 3 one time. That means 1x is going to come out. And then that's why Pranav said root x. So then we're going to have root 6x. 1x left on the inside. So how are we doing this? How are we simplifying these radicals in our heads? What are we looking for? Lucas? The biggest perfect square, right? So when we're trying to simplify in our head, we're asking ourselves, what's the biggest perfect square that goes into this? So the biggest perfect square that goes into 24 is 4. So I'm going to say, okay, well, if I do 24 divided by 4, that means I'm going to, in my head, I'm thinking, okay, well, I have 6 and 4. That 4 becomes a 2 that comes out, and the 6 stays on the inside because there's no pairs in the 6. That's essentially what you're trying to do just in your head. Let's do another one. Let's add multiple variables. So let's say I have 7ab times the square root of 75 a to the 10th b to the 7th. So I'm going to work with the 75 first. What's the biggest perfect square that goes into 75? 25. What's the square root of 25? 5. So we have a 7 on the outside, and now what are we also putting? A 5 on the outside. And 25 times what gives us the 75? 3. So do we agree that 3 is going back on the inside? Okay, a to the 10th power. 10 divided by 2 is 5. So that means there's going to be an a to the 5th on the outside, but isn't there already an a to the 1st on the outside? All right, we'll deal with that later. And then 2 goes into 7 how many times? 3. So b to the 3rd is going on the outside. And what's the remainder? B on the inside. So now on the outside, I'm going to have to multiply all of these. 7 times 5 is 35. A to the 1st times a to the 5th is a to the 6th. B to the 1st times b to the 3rd is b to the 4th, root 3b. Okay. Don't get scared by the variable. X to the 4m, we're going to do the same thing. 4m divided by 2 is what? 2m. That's it. So just x to the 2m. So now I'm going to have x to the 4m plus 2. Well, don't you guys agree that this is x to the 4m times x to the 2nd? All right, so we just treat them separately. X to the 4m divided by 2 is x to the 2m. X to the 2nd divided by 2 is just x coming out. Well, when I'm saying divided by 2, you know, I mean, I'm just dividing the exponent by 2, right? So this is just x to the 1st. Anything left on the inside? No. Can I leave my answer like this? No, they have the same base. So what does the rule say? Keep your base and do what with your exponents? Add them. Can I have just divided 4m plus 2 from the beginning altogether? Yes. Okay, you guys try this one. X to the 2m plus 1. Who has an answer for me? Steven? Anybody need to see us do this? See me do it? No, we're good? Okay, great. You guys try this one. Okay, so I'm going to start off with the x's. 7a divided by 2. It doesn't 2 go into 7 3 times? 2 goes into 7 3 times, so I'm going to get x to the 3a on the outside. Are there any x's left over on the inside? Yeah, because 2 goes into 7 3 times with a remainder of 1. So there's an x to the a left on the inside. Now we're going to go to the y's. So I'm going to treat these separately. 7a divided by 2. Again, I'm going to get that 3a, and I'm going to get an a left on the inside. And then when I have y to the second, right, if I take that exponent of 2 and divide by 2, I get y to the first. Anything left on the inside for that y to the second? No. Anybody confused with how I got any of the variables on the outside of the radical? Okay, so now we multiply. So I'm going to have x to the 1a times x to the 3a gives us x to the 4a. And then I have a bunch of y's. You keep your base, and what do you do with the exponents? Add them. I'm going to put it in alphabetical order. So it's going to be a 3a plus b plus 1. Does it have to be in alphabetical order? No. Root x to the a, y to the a. How many people got that? Great. Okay. So I lied when I said we were done with factoring, but it's not like crazy factoring. Let's show you. Sometimes it still sneaks in, even in chapters where we don't want it to. What do you think the most common mistake for this problem is? I don't think I usually see people adding these together because they're not like terms. I think usually we're good on that.
Pulling the groups down factor, outs of the.
No, that's what we want to do. That's not a mistake. That's exactly what we want to do. Okay, so Stephen?
Like square rooting it before factoring.
Yeah, so square rooting these each separately. So that's I'm considering them individual terms as if it were multiplication between them and simplifying them. We can't do that. Why can't we square root them each separately? Because of the addition sign. So we can't do that. But we do want to do what Tara said and pull out our GCF. So if we have 16w to the third, 48w to the second, plus 36w, there is a GCF of what? More than just w. 16 doesn't go to 36. 4w. So we want to pull out a GCF of 4w. And then we are left with w squared plus 12w, sorry, 4w squared plus 12w plus 9. What do you think we could do? Factor, yeah. So now we're going to have 4w times 2w plus 3 times another 2w plus 3. See how this is all multiplication between these? And you also see that this is the same as saying 4w times 2w, the quantity of 2w plus 3 squared. All right, I can treat them separately between the multiplication sign, right? So let's take the square root of 4w. What's the square root of 4w? 2. So I can pull out that 2. The w, do we agree, stays inside the radical? Okay, and now I'm going to take the square root of that whole quantity of 2w plus 3 squared. What does that happen? What happens with that? It's just a 2w plus 3. Perfect. Is it important that I put parentheses around that 2w plus 3 on the outside? Absolutely, because that whole quantity needs to be multiplied by the 2. Anything else left on the inside of this radical? No. So I would be okay if you left it like this. If you didn't, if you wanted to distribute in that 2, you would get 4w plus 6 root w, you would still need it in the parentheses. Why? If you didn't have the parentheses, it would be 4w plus 6 root w. What would that mean? It would mean that that root w only belonged to the 6. Does it only belong to the 6? No, it belongs to this whole quantity. If you wanted to distribute in the root w, could you? Sure. Do you have to? No. So this we know is wrong. If you wanted to distribute it in and say 4w root w plus 6 root w, I would be okay with that also. So I'm okay with any form of this. Okay, let's talk about adding and subtracting radicals. And again, guys, all our variables are going to be greater than or equal to 0. So you don't have to worry about any negative any negative variables. When we're adding and subtracting radicals, it's very similar to adding and subtracting variables. If I have a 4x plus a 3w, can I add those together? No, because they're not considered like terms because their variables are different. It's the same idea with radicals. If the radicand's not the same, we cannot add them. What if I have a 4w squared plus a 5w squared? How do we add that? You get a 9w squared. What does that mean? We just add the coefficients and leave the variable and the exponent the same. It's the same idea with the radical. So if I have 4 root 2 plus 5 root 2, you want to make sure the radicands are the same, and you also want to make sure the indexes are the same, because we will get to the point where we're dealing with different indexes. Are the indexes the same? Yes. So now we make sure the radicands are the same. Again, we're good. You just add the coefficients in front and you leave the radical the same. Okay, let's say I have 4 root 18 minus root 8 plus root 2. Can I add these as they are? No, their radicands are different, but a radical, like a fraction, should always be simplified. If you can simplify a radical, you have to simplify the radical. Can I simplify these radicals? Yes, I can simplify the first two. So real quick, in your head, what's the square root of 18? 12 root 2. Okay, so it would be 9 root 2. It would be 3 root 2, but because of that 4 there, it's going to be 12 root 2. 9 and 2, right? For 18. What about square root of 8? What's that? 2 root 2. And when there's no coefficient in front, it's implied that there's a 1 there. So that's a 1 root 2. And now they have all the same radicand, so we can add them. A 12 root 2 minus 2 root 2 is a 10 root 2, plus 1 root 2 is 11 root 2. All right, you guys try this one.
Is it 45x or is that the
Oh, nope, it's supposed to just be x cubed, no y there. Did that on purpose. So if you simplified each radical, that's what you should have got. Does anybody need to see how I got those radicals once I simplified them? So now when it comes to adding, we can only add the like radicals. So the first radical and the last radical have the same radicand, so I can add those. I can't add the middle one because it doesn't have a y underneath the radical. So we have 4x to the third minus 1x to the third, which gives us 3x to the third root 5xy, and just minus 3x to the third root 5x. And I would leave it just like this. Nothing we can do there. Okay, try this one.
Wait, Miss Alvarez,
Yeah.
can you explain this?
Oh, well, yeah, of course. Did you get my simplified ones? Did you get the same ones as me?
I got the 3x. Get the next thing.
Okay, let's do that one. So for 45, I went with 9 and 5. And then 9 is, yep. So remember what I said, similar to fractions. Like if you have a 4/6, you always have to simplify that to 2/3. So no matter what, if a radical can be simplified, it has to be simplified. So now you see where we got it from? Okay, try this one, guys. So we have the root of a squared b plus the root of b cubed minus the square root of b times the quantity of a minus b squared. All right, who has an answer for me? Maya? I got the same 2b root b. Does anybody want to see us do this? Don't be shy. Everybody got 2b root b? Okie doke. Let's go. All right, so now we did simplifying, we did adding, subtracting. Now we're going to talk about multiplying. And that's the last thing we're going to talk about for today. So I always go back to the rules of variables. If I have a 3x times a 4y, when you're multiplying, you multiply the coefficients, right? 3 times 4 is 12. But then don't you also multiply the variables? X times y is an xy. It's the same idea with multiplying radicals. You multiply the coefficients, but you also multiply the radicands. So let's say I have negative 7 root 30 times 5 root 2. So you multiply the coefficients, negative 7 times 5 is a negative 35, and then you multiply the radicands, 30 times 2 is a 60. And then what should we always do? simplify the radical if we can. If we're going to simplify this radical, I'm going to get 4 and 15, right? 4 and 15. And then that 4 will be a 2 and the 2. So we're going to have a negative 70 root 15. Okay, so no coefficients to multiply, so I'm going to go ahead. I'm going to multiply the radicand. 6 times 8 is a 48. A to the third times A to the fifth is what? Don't tell me A to the 15th. A to the 8th. Very good. B to the 8th times B to the third is B to the 11th. Now that we multiplied, we can simplify. What's my best factors for 48? What are the best factors for 48? Yep, 16 and 3. Why? Because 16 is the biggest perfect square that goes into 48. And what's the square root of 16? 4. So do we all agree that's going to be a 4 root 3? And then a to the 8th, the square root of a to the 8th is a to the 4th. And the square root of b to the 11th is going to be b to the 5th root b. Who remembers from geometry what happens when you multiply a radical times itself? Pranav? Yeah, it basically cancels out the radical. Let's think of why. If I have the square root of 9 times the square root of 9, wouldn't that end up being the square root of 9 times 9? It makes that pair. So essentially that 9 comes out, leaving nothing left underneath. So whenever you multiply a radical times itself, it essentially just becomes the radicand, no more radical. So let's say I have root 6 times root 6. What's root 6 times root 6? 6. What is root 121 times root 121? 121. Now let's say I have 2 root d quantity squared. Can I distribute that exponent of 2 to the 2 and the radical? Yeah, if there were a plus sign, could I then distribute it in? No. So what's 2 squared? 4. What's root d squared? D. So we just get a 4d. Curly? I'm going to do a problem like that. After this problem, I'll do a problem like that. What do I have to do here? It's a binomial times a binomial. I heard it. FOIL. We have to FOIL. So we're going to have 3 root 5 times 4 root 5, which is going to give us 3 times 4 is 12. Root 5 times root 5 is 5. Then we have 3 root 5 times a negative 6 root 2 gives us a negative 18 root 10. Am I done? No. Now we have to double distribute that root 2. Root 2 times 4 root 5 gives us a positive 4 root 10. Root 2 times a negative 6 root 2 gives us a negative 6 times 2. Everybody okay with how I got all those products? All right. So now I'm going to simplify what I get. 12 times 5 is 60, negative 18 root 10 plus 4 root 10, and then negative 6 times 2 is a negative 12. Are there like terms? Yes. So we need to combine the like terms. 60 minus 12 is a 48. Negative 18 root 10 and a positive 4 root 10 gives us a negative 14 root 10. Can I distribute in that exponent of 2? No, because of the minus sign. What do we have to do? We have to FOIL it. So 2 root y plus 2 minus 3 times 2 root y plus 2 minus 3. So when I have 2 root y plus 2 times another 2 root y plus 2, we're going to multiply the coefficients. 2 times 2 is 4. And what's root y plus 2 times another root y plus 2? No square, just y plus 2. The radical cancels, right? Is it important that I have parentheses around that whole quantity of y plus 2? Yeah, because that 4 needs to be multiplied with it. And then I'm going to have 2 root y plus 2 times a negative 3, which gives us a negative 6 root y plus 2. I'm not done. Now I need to double distribute in that negative 3. So I get a negative 6 root y plus 2. And then a negative 3 times a negative 3 is a positive 9. All right. When I'm simplifying, do you think I need to distribute in this 4? Yes, because of the plus signs, it's going to make like terms that I can add together. So if you don't distribute in that 4, you're going to get points off. So we need to distribute in that 4, and we get 4y plus 8. Do we agree these middle terms are like terms? So we get a negative 12 root y plus 2 plus 9. Am I done? No, why am I not done? The 8 and the 9 are like terms. So I have 4y minus 12 root y plus 2 plus 17. Okay, you guys try this one on your own and then we're done. The quantity of 6 root c minus 5 root d quantity squared. Yes. So let's bring it back to like normal numbers that we can figure out. Let's say I have 6 plus 10. I'll make it easier. 6 plus 3. Let's say I have 6 plus 3 squared, right? Okay, normally according to PEMDAS, we have to simplify what's in our parentheses first. So 6 plus 3 is 9, and then 9 squared is 81. Let's say you distributed this in. You'd get 36 plus 9. Is 36 plus 9 81? No, it goes against the rules of math, but let's say it was multiplication between here. So if we're following PEMDAS, it says multiply first, right? 6 times 3 is 18. And then 18 squared is, does anybody remember? 324? Yeah. Okay. So now let's say we distribute that. 6 squared is 36. 3 squared is 9. 36 times 9 again is 324. So it's just, it works for some, it doesn't work for the other. All right, guys, what'd you get when you squared this, when you multiplied it by itself? Arav? Minus 60
No, plus
plus 25D. Yep, I got that. Everybody else get that? Okay, great. So we have homework tonight. I will post it on Classroom.